Okay, so this is our first lecture on digital control. In this lecture we will be giving an introduction to digital control and explain some of the main advantages and disadvantages regarding the digital control. Okay, so this is the block diagram of the system. So as usual, as we used to see, so we have our input signal, or the reference input signal that we usually apply to the input, and then we have the controller output signal, or the output of this of the whole system, and this is our new digital controller. All right, so the process or the block diagram goes as follows. So instead, earlier we used to have only a continuous time controller that was operating in the continuous time domain. Now we have a digital controller which is operating in the digital domain. So we would expect that the digital controller, okay, it takes some digital samples and values at its input, and then it produces some digital outputs, samples, and then those outputs go through a digital to analog converter, which is usually like a zero order hold in some systems, but not all of them. And then we have our system, our dynamical system, which in general is a continuous system, because usually most of the times we actually control systems which are in the continuous time domain, not discrete time. I mean, most of the real physical systems are continuous time systems. Okay, and this is the output of our system. We try to sense some variable from the output, as we do in feedback control, but then this sensor usually transforms some physical quantity, it transforms to an electrical signal. Okay, and then this electrical signal in most sensors is also in a continuous time nature. So what we do is that we pass it to an analog to digital converter, this block. Okay, so this analog to digital converter, it does two things. It performs sampling, so it does the sampling of the continuous time signal at regular intervals, let's say t, and then it does quantization. Okay, we will explain those two maybe later in more depth, but the basic idea is that you should take enough samples to consider all the variations in the signal, and also in the quantization you need to represent each sample by a discrete number at the end. So in order to do that, you need to divide your amplitude level into a set of levels, certain number of levels, and then you try to approximate each sample with the closest level. So this is the quantization step. So you lose some precision by this quantization, you lose precision in the amplitude domain from the quantization, and you lose some precision in the time domain from the sampling. And then you have the digital samples which come out from the analog to digital converter, and these are then passed through here. So the reference is also applied in the digital domain in this case, and so all of this block which is encircled in the green box here is basically digital. So digital means that it can be it could be on a microcontroller or microprocessor, it could be implemented on an FPGA, any of these kind of implementations. One more thing just before moving to mention some of the advantages about digital control. So before doing the analog to digital converter, or before the analog to digital converter, usually we perform some sort of a filter. Here there is usually a low-pass filter in addition to the ADC, or before the ADC, and this is an analog filter, and the main purpose of this analog filter is called an anti-aliasing filter. Okay, it's an anti-aliasing filter and the main purpose of this filter is to restrict the bandwidth of the signal to be within the Nyquist range of the sampling time that you're using in the ADC. So you want to make sure that no aliasing is going to happen, so you need to have an anti-aliasing filter in order to restrict the bandwidth of the signal to that Nyquist bandwidth. Okay. Another use of the anti-aliasing filter is that also usually you have some high frequency noise, so it's also removing this high frequency noise as an extra bonus, you can say. So this is like the main block diagram of the digital controller, and we will be using this quite frequently. One of the interesting things about digital control is that it's one of the branches in which you have a mixture between digital or discrete systems and continuous systems together. So you have both of them at the same time, because most of our systems are usually in the continuous time domain, okay, and they are, even most of the time, they are not electrical even, so they are continuous time, and they could be mechanical, they could be fluid systems. So there are different kinds of systems. They don't necessarily need to be electrical, but the thing is that they are continuous time, while the controller here is in the discrete time. So this is one of the interesting things that will require some of our attention during this part of the course. All right. Okay. So